It's right around 7.
I'm a little worried. Is it the slides for Thursday or just me doing firewall stuff? I think we'll try that.
Well, we can go over, we had some in-depth stuff for CCDC last year of containerization. I think that's probably best, and if not, we can figure something else out. Because I know Krish had FireJail from before, and that could be good for locking down web apps.
That's cool, but yeah, I don't want to present like
Yeah, I think you and Michael are, I'm taking Linux forensics next week.
that's cool.
So I do think, yeah, like what Ronan's saying, if we get a game plan for that, like now, before CCDC starts, that's pretty chill.
Yeah, no, for sure. It's just I don't have enough experience with firewall, so.
All right. It's just I don't know if everyone is, because I wanted to go over this with Michael, who I would say. Cyberforce is coming up. We should be registered. If not, we get that over the next day or two.
Should I do registration for that?
Michael said he was going to do it, so I will go bug him and see if it went through, since that was about a week ago. We still have 2 weeks to register, so it's not like urgent. This is a pretty cool competition. You're basically doing live response for cyber defense in like a simulated power grid. I think last year it was windmills, if I remember correctly. So it's fun. I don't know what the team size limit is. I think 8. So just let me know if you guys are interested in going out and doing that. It's fairly low pressure. Half of it is done before you get there. You'll be given like I think 2 weeks to go get in and preemptively secure some of the boxes, and then you're going to have someone there that's going to be totally vulnerable, and you go in on site and you're trying to defend both of them. It's under like very, very strict time pressure. So it's a good time. I think as of last time, SIGPwny paid for all of the trip expenses. So yeah. Michael, any last minute like things on Cyberforce? We're good to go for that?
Yeah, I'm just waiting for the confirmation email.
Okay,
I
cool.
got us registered for a first squad, that's not a permanent roster, so I just need to get access to the portal so we can change people in and out. Because I know that our last year's squad is not going to be the same stuff.
Yeah, okay, and it's 8, right? It's the team size limit, or I was 8, okay.
People.
6?
6.
Okay.
Yeah.
All right.
You can register for multiple teams, right?
Now, I have to get the first registration to go through in order to request. I sent the emails and that too, but haven't gotten a response yet. So I'm hoping that after the first registration goes through, she'll say yes. We can run a second team in.
Okay.
I can send an email to her as well, if that's the case.
Okay, yeah, let's just see what the interest ends up looking like. But if we have more people than slots, that's always something we can do.
Guys, I can put out an announcement at some point. I'm hoping she gets back to me during the week, my day of the week. You'll hear from me and I'll ask who's interested in doing that. Is that something? Okay, sweet.
All right, cool. So, yep, that's the main flag for today. It's a reference to directory brute force, which we'll be getting into. And as always, if you guys want to go into this, the slides are on the SIGPwny.com/memes. Okay, so let me give some context as to why this is sort of different from the SIGPwny general web meetings. They're pretty much complementary. But when you look at red teaming like large networks, right, like a whole enterprise, you're typically going to have a couple different points of entry that are on the sort of network's perimeter, right? Because you're not able to access anything on the inside. And one of the really big ones is web apps. It's constantly battling year over year. I think as of last year, web application compromise actually accounted for more perimeter breaches than phishing, which is kind of a big deal if you think about how prolific phishing is. So this is going to be one of like the 2 sort of main go-to techniques for getting access to an enterprise or corporate network that's not that you can't go on site, right, and like physically get in and start going after like Wi-Fi and ARP spoofing and such. So this is really important, right? So you can't get into the perimeter of a network, and there's not anything else you can do, right? It's totally locked out. So we're going to go over a little bit of reconnaissance techniques to go figure out, how many websites they have, what domains are they mapped to, if these sites have any additional functionality we can look at to try to exploit or just gather more information, and some techniques related to that. And then I'll also be going over briefly, like rapid fire, additional sort of exploit primitives, right? So everyone here, I think, has familiarity with cross-site scripting and SQL injection. There are a lot of different vulnerabilities. Like you can just have authentication that doesn't work, that's a big one. There's all sorts of vulnerabilities that can come up if you have a website that's doing like flat file serving. of like your files in a directory, and if that's not properly sanitized, you can get arbitrary code execution sometimes doing that. Websites can mismanage file uploads, and going through all that pretty quickly. All right, so this is a pretty important slide for context. So in a CTF, a lot of times you're going to be given like a really obvious sort of name, right, that hints to like what the class of vulnerability is. You begin a website and say, right here is vulnerable, and you spend a lot of time finding this very bespoke exploit to get in and do whatever your actions and objectives are. And usually your action objective for CTF is just get the flag, right? So many times you're limited to like, hey, we need to read the file. It's pretty rare that you're going to be going in and like getting a shell, right, or taking over the server. And there's a lot of things also out of scope for CTFs. Like you are not going to be brute forcing, like 65,000 logins. Like no, don't do that. So it's important right for you to go, not to off-ball it or anything like that. Now, real life tends to be different. I mean, there's no like set pattern for anything, right? But a lot of times, your actual objective for the web server is to get in and use it as a pivot point to be able to talk to things on the internal network. That's your goal. So usually the way you want to go about that is getting some sort of arbitrary command or arbitrary code execution within the server and delivering some sort of like backdoor or implant and then routing your attacks through it. So it's very, very different. Now, sometimes you will find really important things on like, a website at the perimeter, but that's just generally not something you can rely on, right? You can always rely on routing into a target network through that. So usually you're looking at server-side exploits or database compromises to let you get remote code execution. Some databases will allow you to get remote code execution when they're compromised, like Microsoft SQL servers generally will do that if they're not configured super strictly. And then lastly, in real life, you can do pretty much whatever it takes, right? You can send out massive numbers of requests if you have to. You can try to brute force into things, and even if you want to avoid that, you don't have to. And finally, right, sometimes you'll see that there are already exploitable pieces of software running that are completely exposed. And if that's the case, then you don't have to spend a lot of time finding some bespoke exploit. You can just look it up and see like exploit DB, maybe modify it a little bit, and then just send it over. So in this case, there's a whole new dimension to web hacking that is not just doing the exploit, right, but figuring out where the vulnerabilities are. And a lot of times that really is like more than half the battle. It's just mapping out all of the assets on that like target network. And this gets really hard if you consider like the massive scope of a lot of like businesses, right? There's going to be a lot of ground to cover, and you're going to come in knowing basically nothing about what the server is. You're not going to know, what language is it built in, what OS is it running on, and you can get some of that information out, like with the security meeting. You can give it a scan and see, hey, this is running PHP behind Apache on like Ubuntu 24 server or something, right? And try to put that information together. That's really important because you're trying to get in and get command execution. We need to know what software is running, what OS is running. So there's going to be a cycle here of basically enumerating, which is a term for doing active reconnaissance and figuring out what is on the target, exploiting it, and then once we get there, what else can you see, right? You re-enumerate, you re-exploit, and you keep going. So I'm going to go over basics of how websites work. I was going to say, this is not like my area of expertise. I'm competent at web hacking, but this was not like what I was doing professionally. This should be more than enough to get some background on attacking this. So one of the most common enumeration techniques is figuring out how many URLs can we get, right? If you look at it, like websites are typically going to mimic some sort of flat file structure. Sometimes they are a flat file structure, right? And going into the URL help you access certain endpoints. And including a website where it appears really, really boring, but they have weird things that are accessible that maybe should not be accessible. So let's say it's like a boring website with an admin URL we can go into. And it's like WordPress, right? WordPress, for a long time, if you logged in as a WordPress admin, you could edit your plugins. But your plugins are running PHP on whatever the WordPress server is. If you could find the admin page and get an admin login, then you could just modify it and go run arbitrary PHP code on that server. Right, so that's an example of why you want to be looking for these things. Because in that case, like the blog that you're looking at is not interesting to you, but you have an avenue potentially for code execution. The other thing is you can find exposed confidential information that maybe it doesn't get you code execution, but has other really important things. Like one super common finding you'll see in real life is business confidential or worse PDFs. Just like in an open file server, like an AWS bucket or something. And you never know what you're gonna get. Sometimes it's not necessarily gonna be credentials to get you access, but there's like fun stuff in there. Like one of the worst ones I had seen was a list of all company invoices over the last year and exactly who it went to and like what it was for, stuff like that, right? So you can still get information disclosure. And finally, if you have anything for source control, that's always worth looking at. Like if you have a .git on the site, like that's first off just bad in terms of like the vibe you get, right? It indicates sloppiness. But also if you go through, you might be able to get the source code or like API keys or something like that actually baked into the website. So how the directories are served, again, it completely depends on what the server is. Some of them are not going to be a file system. It's going to look like that. Some will be serving with a flat file system. But basically, kind of like the port scanning, right? We just try all the ports and connect to them. What we're going to do is you can just make a list of the most common directories statistically and just try like 10 million of them. This is called directory brute forcing or drill busting. And this is a very, very common method to go enumerate what is on your website when you're doing penetration testing. This will generate a ton of noise, right? Because if you have a list of directories, right, that's like 10 million long, and you're not recursing, and you're making like 10 million requests. And if you're doing it recursively, right, like you end up having to boil this directory, and who knows how many it'll be. So be conscientious of that, especially if you're going really, really fast. Another method that does a similar thing, but does it differently, is spidering. So spidering basically says we're going to define our target domain, right? So let's say we're going to refresh site amazing.pwny, if you're doing that in the CTF. And then you'll visit a web page, you'll visit a couple web pages manually. And then what your browser will do is it'll go grab that and see what other links are in here, and we'll follow those links recursively. Sort of like a depth first search to go see how much can we reach. This will often give you a different list of things that your busting will, depending on how the site is set up. So it's worth doing both. And common tools to this are GoBuster, FairXbuster, and FF, which is the post faster useful, like meeting flag. These are all ones I've seen folks use pretty commonly. Is that right?
But what about GoBuster written in Java?
Yeah, there are a lot of drill busting tools. One of the old ones I used when I was getting started was drill buster. It's like this fat Java GUI, and you go clicking, like typing your target, and then you're like dragging the word and hit go, and it take forever. Terrible piece of software. So
are you like directory converting calculator? Do they have notable differences, like differences between Mac and Rust?
Not really. FairXbuster is, I think, the fastest, but FF is really fast as well. Like they're all quick. Honestly, I think they're pretty much interchangeable. Even the syntax is going to be almost identical across all of them. So it really is just a matter of personal preference. And I think all three of these are installed in the PwnyOS box. So you can just use whichever one you like. So yeah, drill busting is not complicated, right? Like you're basically just going to set your target. This one defaults to that word list in cyclists, and just change it to smaller or bigger. And then we just set it, and they'll go through all of them. You can see right there, right? That's one other way of seeing the file manager endpoint, and it'll go through and get pretty much everything on the site. Of course, not guaranteed to find everything, but in practice, it'll get like 90% of what you need. Okay, in this example of spidering, using Burp Suite. I don't really have time to go into how to use Burp Suite. At least I did. It's really good software. It can do like a bunch of different things, including grabbing requests and modifying them. But there's a feature called Scope, which is really useful because you just put in, hey, this is the domain we're targeting, and then you can open up their own like Chromium browser, and you can go just visit the site, right? There's no more just poke around on your own, and then you come back and go to this targets page here, and it'll give you a sitemap and reconstruct it by spidering it. So this will generate a lot less traffic as well than drill busting because you're only visiting the pages you actually visit. You're not brute forcing anything else additionally. So spidering is good if you just want to go like poke around something before you actually run a more aggressive tool. Okay, vHosts. vHosts are a little bit annoying. The main reason I'm bringing them up here is because you'll see them a lot in CTFs. In practice, in real life, doing things with DNS is more common. But virtual hosts are ways having multiple domains to one IP. And the way we can go through with this is a lot of times we'll visit and we have 301, we'll be like, hey, we need to go to this like host name, and then you have to go to your etc hosts file and add that in. So etc hosts is kind of like a DNS record list you keep on your computer. You can do a look locally first before it asks any other server where those things are. Right, and all you do is you get that redirect or whatever it is that takes you off as the vHost, enter in that hosting for IP, you can enter in the hosting in your browser, and it'll take you there. So vHosts are not the same as subdomains, even though they look pretty similar. And this is important just because sites will oftentimes respond differently by host name. So the site we have in the site range will do this, or if you want to visit it with fresh site on amazing.home, if you visit it by IP, they'll just return 301. Now, substitute.
So what is this like used for? It's like, why would you run those multiple domains to one IP?
Yeah, so let's say I have like a big Apache server, right? And I have like a bunch of compute on it, and we have a bunch of people wanting to run like small blogs, right? And I have one IP address for that server. But you want like Joe's blog and let's say an e-commerce site, whatever, right? And the idea is via vHosts, you can enter that in, and it'll let you have all of these websites on the one IP address versus, I think for DNS records, it's one-to-one. I'm not an expert on DNS, but I think that's how it's set up. So that's the idea. You have a bunch of like little sites all on the same server, all on the same IP, and have it resolved that way. So,
still a question on the directly enumeration. So I just want to slide on the web page and you didn't cover Nixo over there?
yeah, I was going to get into Nixo later. Yeah, Nixo is technically, it's on the border of being an enumeration tool or an attack tool, but I'm going to Nixo and SQL map and stuff towards the end. So yeah, I'll go over it. Don't worry. So domains are way more common than vHosts, at least in my experience. There needs to be a top-level domain and public DNS records. I think everyone here knows loosely how DNS works, so I'm not going to get super into it. But kind of like for the NetSec meeting, right, we're going to server-specific recon. We can figure out where a lot of sites are just by looking into DNS records. And there's a whole host of techniques you can do to go enumerate DNS. And they're pretty easy to go look up what this content's covered. If you do like OSCP, if you do try hacking, if you hack the box, they'll go over like all of these. But you can use automated tools like DNS Recon or DNS Enum. You just put in, you're like, hey, here's my DNS server. Here's what I want to look for, find everything related to that, right? And we'll just go. Or you can do it manually with Dig or NSLookup. And both of these will let you figure out, right? Let's say I have like one big domain like Microsoft, and I'm going to see what all the Microsoft servers look like. I am realizing this is probably way too small. So hopefully you guys can read it. If not, you can just put it on the slides. This is the example of Dig manually on the top left, where we begin like, hey, what IP does this host name resolve to? And then we'll say, hey, yeah, I have an answer for you. It's 192.168.10.10. And another one is I ran DNS Recon and said, hey, I want you to look for this domain. Fresh ending up home, so you can find anything else. In this case, there wasn't anything else, because that's just the one domain. In contrast, I ran the exact same command and went to Microsoft.com, and I got this huge list of things. So one important note is that for whatever reason, legally, DNS Recon counts as passive reconnaissance, meaning you can point it and do it against anyone, it's completely fine. That is not true for things like Nmap or Dirbusting. You cannot be Nmapping or Dirbusting Microsoft. Don't do it. But for DNS stuff, it's okay, right? And we can use this to go like list through a bunch of records. So if you're playing like a pen test or red team engagement against a big company, you can start something like this, right? And just look for what DNS records they've exposed. So there can be a lot of them, doing a lot of different things. All right, cool. So there's a couple of things people do, right? Now that we're actually like looking around on our target to recon valuable things. Right, so if you have like a .git directory or some source control on the site, that's pretty bad as you can find source. The other issue is a lot of people, even here, would go commit credentials and API keys to their public GitHub. This is really bad. Like when I was doing CS222, I was like, just to troll people in my final presentation, I included a slide of everything I could find from my classmates' Git repositories just for that semester. I got 2 net IDs and passwords, tier 5 GPT API key, Spotify premium, a couple brand email accounts, right? List goes on. Anyways, this is very bad because you can imagine if we had one of those situations where you have like a dangerous admin login, like the WordPress example, that's very, very common, right? If you have authenticated RCE. Well, if you have the authentication material sitting on the internet, it's not going to take attackers a very long time to be able to authenticate. So this is just something to keep in mind, right? Depending on whatever your target has publicly. This is super, super common. Another thing you can look for is just technical information to disclose the actual site's tech stack. Generally, it shouldn't be too hard to find. The conclusion would be like, I don't know what this thing is, but it's running. And you can go look for like a PHP version page or something like that. Another important thing to look for is occasionally you'll find either a robots.txt or a sitemap.xml. These are really nice because they will theoretically give you some information on the layout of the website and you won't need to go robust it. So robots.txt tells like spiders, like don't visit these because they're not, they're for people. And sitemap, I believe, is just a listing hierarchically of what the actual like URLs are on your site. So those are all worth like looking for. These are all like really, really easy, right? You can look for all of these things combined in like 5 minutes per website. So yeah, that's an example. Another thing is you can look for like commit messages, someone's like, hey, remove credentials, right? Well, that's not good. Because you can just go back, run commit, and like find the diff and find the credentials. Yeah. So on that note, I think I mentioned this a couple times already, but if you can find any kind of admin login, it's going to be worth it to at least try to get in, because in terms of threat modeling, right, a lot of people are, for whatever reason, okay with authenticated RCE. Another really big target is anything DevOps. If you can get into a GitLab or something like that, where you're actively writing code and then pushing it off, even if you can't get into that GitLab server, if you have a valid login, and these guys are doing, let's say, 90 builds onto a target that's going to run, you can basically go pull like a mini supply chain attack, right? Because you have the ability to go more than likely really run to at least one repository. So you could always plant malware that way and just wait and see, is it getting sent to some runner, right? Are there other people in this organization that are using that code and running it, or even better, running it privileged? So that, it's a little rare, but if you can get into a GitLab that way, that's a pretty easy way of pivoting immediately into like, someone's internal network, and making it really good execution. So, another thing is always check for default credentials. Like this sounds really stupid and really obvious, but you'd be shocked if you open a site like Shodan, which will look over the entire internet and you just punch in the default credentials for like something common, how many hits you'll get a lot of them. Another thing is having your username integration. So normally the website, when you get your password wrong, it's say invalid username or password. It's actually really bad if a site says invalid password, right? Or this email doesn't exist. Because if I don't know as an attacker, if it's the username and the password that's wrong, you can't really get a lot out of that. If I know, if I can tell if the username is right or wrong, well, I can just have a giant list of usernames, or I can do a scrape it off of like people's LinkedIn and make a list that way, and just try it and start seeing who has valid logins. And that's going to reduce the actual like space of things I need to try a lot, right? So that's an important thing to go look for. The last thing is there any kind of rate limiting or lockout for authentication? Sometimes it's as easy as looking it up. Other times you might need to go see it's an open source piece of software, go through it and look for the code. And other times it's just a total black box and you just have to like try and see what happens. But if you want to actually brute force into things, I recommend using Hydra. WorkSuite also has a very easy to use module called Intruder, where it'll just let you fill out these HTTP forms and brute force that way. The issue is the free version is partially rate limited. I think you can get around 2 requests a second compared to like thousands with Hydra. So if you can learn the syntax, because Hydra can be a little bit annoying to work with, I recommend using Hydra for this. Okay, so, well, everything we're going to get into is web shells and code execution. So execution is going to be dependent on what the actual server is running, right? So if you have a server that's running C#, you probably need like an ASP.x file to go run a web shell. If you can't run a PHP web shell, it's a C# server. So this is why stream reconnaissance is important. The other thing is, you want to know what the underlying operating system is? I've had a number of times, I'm sure folks who hack frequently will see this, we get a web shell on something and we start doing Linux commands, and it's like, oh no, my web shell doesn't work. What happened? I got the wrong command. No, we can't ls from the command prompt, right, on Windows. This exploded. So that's why I actually have to know this stuff going into it. Otherwise, things are just going to randomly fail. And that goes double with an antivirus sort of moment if you're actively messing with it. So you can start looking at tech stacks because it feels like web is pretty cool because you'll just like walk it and see what technology the site is running, including the server, programming language, maybe the operating system. It really depends. Gosh, there's a browser extension you can use for things called Vaporizer as well, Ronan analyzer. You can just have that in your browser. Yeah, actually have it on the slide. And that way when you're visiting a site, you can just click and see, hey, what's this tech stack? Probably. And just grab that from like headers right from the server. So yeah, web shells are a common primitive when you have any kind of file upload vulnerability. So if you have the ability to upload a file that the server recognizes as code, then you can do a web shell. And a web shell is like not a very complicated piece of code at all. It'll usually be like, hey, like Python can be like a subprocess.run, whatever is in the URL, right? It's like really, really easy. You can calculate a bunch of them in user share web shells. Just know that in real life, all of these are going to be flagged with viruses as they should be. If you want to be a little bit more sophisticated, right, like we talked about, like not only the compromise stuff and the other bad guys get in, you can have a web shell that acts like a real shell, because you guys are all proficient programmers. It should be hopefully decently apparent as how you would do that. It's like not a lot to go change to make that the case. So this is an example of PHP web shell, right? This is like dead simple in terms of how it works. You just go to like wherever you upload a file to, right? And this is looking for a parameter in the URL, where's command, and this runs it as a command in the system function in PHP. So that's what a lot of these things end up being. They're very, very small. So the other thing I want to go over is automated vulnerability scanners. So this is where I was thinking is Nikto. So Nikto will basically, like, if you can imagine, you're like one check for a given vulnerability, like a request you send to the website. Nikto has like a giant list of vulnerabilities, and then just try a bunch of them, right? So it's kind of like dirt listing, but for known exploits. This will generate a ton of network noise, and will usually take a long time to go run. So this is something I would use in CTF if I was doing like vulnerability auditing, right? If you're going to be hacking anything stealthily, 765,000 requests is not the way to go. But it is really good at finding vulnerabilities you might not think of. Like, I remember one time I was running on a target and I couldn't find anything vulnerable in the site, and it's because they were using an old version of PHP, where PHP itself had an exploit. You can get in that way. And this thing I never would have thought to do manually. So it does absolutely have its uses. If you have a SQL injection vulnerability and you are a complete script king, you can use SQL map. You can grab a request from Dope Suite and pass it with the -r parameter, and it'll be like, okay, here's the parameters in this form, which are SQL inject all of them. And then we'll run heuristic tests and see if the response differs, and it'll just do everything for you. Like if you can't get response back from the website, it'll do that statistical analysis based off of sleep commands to go start like brute forcing things out. Like it's a cool tool. The other thing is there are some instances like the MS SQL where you can get a shell from it and you just patch that shell, and they'll just, if it's vulnerable, just churn through it and end with a shell on the target. So it's really fun if you've never done it before to go like punch it in. In practice, any kind of web application firewall is going to catch this. Any like competent human doing sysadmin is going to catch this. So it's absolutely still like necessary to know how to do things by hand on your own. But it is cool to know about. And if you have like a blind SQL injection, which is, I think we're going to have this in the meeting, but when you're SQL injecting and you can't see the result, then using automated tools is going to be necessary because you just can't do that by hand. All right, so that goes over like the recon portion of this, right, of gathering information, looking for vulnerabilities, additional ways in. And now we'll go over some additional like vulnerability classes, right? Because there are more kinds of server-side exploits than just cross-site scripting and SQL injection. A big one is directory traversal. The reason is this is common, especially with like older models of sites, is already storing files in like so you might have a directory, right? It's like index.html and then like team.php, right? And the server will just basically go up, grab one of these files, and you'll only run it like index.html. The issue is, if you don't sanitize that import, you can just go into whatever file. And this can be really, really disastrous depending on how it's set up, right? Like, let's say if you have it running as like a user account, right, which is uncommon to deliver data, but it's possible. You would grab an SSH key, right, an SSHN. Or a more common thing is, you can't get OCE, right, so of course, you just use it to get the source of the website. And you can maybe grab from that source of talking to a database, right, with your database login and password. Or can you go read, right, like valid logins or things like that. So this is like an information disclosure primitive. And the common way to test this is you just do a bunch of dot slashes in a parameter that looks like it's serving a file, right? So if you have like, website.com and then page equals about.php and then you go around and you see, right, hey, click on the one to take you to page equals index.html. What if we try page equals slash as the password, right? And see if we get anything back. Now, I think most websites are not going to be doing flat file serving anymore, but this was very, very common for a long period of time. The other thing is some of these are like really dumb, like simple, I should say, like filters, or like, hey, don't do // and then you can get around them by saying, hey, I can do .. // and say, hey, no, / is bad, cut it down and collapse back into it. So if you don't have a recursive filter on some of your website, there's always ways to get around like application firewalls. But yeah, generally it's a very bad idea to sort of follow by parameter. Thankfully, a lot of the major pieces of software doing this are not going to have these vulnerabilities anymore, like that we know of. But it's still worth knowing about. So this is an example of what a patch reverse would look like in Python, where you can basically maliciously use this to go read an arbitrary file on the box, assuming you get permission. Okay. Local file inclusion is like directory reversal, but 10 times worse. Because this is where, instead of reading a remote file or a local file, we execute it, right? Explaining this is really hard if you don't also have a file upload primitive. Like, you have the ability to get a file somewhere on the machine, there's only one way to go exploit this. And it's kind of like mind-bending, at least I don't know kind of mind-bending when I was doing it, which is that if you only run legitimate files that are already present on the target, how are we going to get the web shell in there? And I thought this was pretty crazy. You can send the web shell doing nothing in a web request, and we'll get put in a log file. And then we can use the local file inclusion, which lets us run whatever file, and have it visit the log file, right? And if the web shell's at the top of the log file, when that happens, it'll actually run that code. This is like super, super specific and super finicky. So we get one shot, right? If you miss a bracket and you send it in there, that's when the developed code's not going to work. But this is a really cool exploit, right? In terms of the primitives that you have. Like, how would you actually go run code if you can't put files? It's almost like raw, but for a website, right? So this is why it's kind of important to think about things in terms of capabilities you have and chain them together. So I'm kind of picking on PHP because PHP has some of the worst security practices, and they're going to vary, right? Like C# has more problems with insecure deserialization, but PHP, they can do things like wrappers, which will just get arbitrary code execution because a wrapper, you think of the filter is what it's called, is like the interface for functions that can be very scary, like fopen or include, which include is kind of like include in C, but also exec from Python, all in one. And then if you're calling include, right, and you can supply data through this filter, right, and the filter is like, hey, we have this really cool I/O abstraction. We're going to send I/O and run in base 64, right? Well, if you're getting that from the user, that's really bad because in base 64 I'm getting my web shell and feed them and you're getting execs. Right, and then you can just do that by curling it and seeing. So I believe this is an extension for PHP that's there out of the box. You have to turn it on. It's kind of like a standard library type thing. So if it has this extension enabled, that's something that's worth trying. But this is another example of why it's important to know what technologies the server is actually running. Because a lot of times, especially with automated scan-off function, we can do this dangerous thing, and then you look into it and it's like, oh, this is kind of crazy, right? But these like language-specific techniques, they're going to vary all the time depending on what your target is. Like this would not ever work against things like a C# web server running on Windows. Lastly, I'm going to go over briefly my final conclusion. This one is especially rare and has still happened before. And it's like local file inclusion, but you do it on a page. The testing process is very similar to local file inclusion, so I'm going to really go over it in too much depth, but you can try URLs. And this is a very, very dangerous exploit to run, right? So you just point it to your like malicious web server with your web shell and just go run it. And this one, on the other hand, unlike the other vulnerabilities, this one's very, very common. So if we have any ability to execute files that we upload, right, it's going to be an immediate win as an attacker. And most of the time, when this happens practically, is when whatever the upload filter is does not sufficiently ensure that we're uploading what we say we're uploading. Especially if it's a really bad, so it tends to be operating on a blacklist instead of a whitelist, in which case getting on the filter is as easy as knowing like some really coarse file extensions that do the same thing. So look at the profile picture upload, right? And it loads the profile picture and renders it, and renders that code, or data, I guess. But when you upload the code the server recognizes, that'll oftentimes let you just get code execution. Now, modern file upload filters should generally be better. Like using a library, it should be a whitelist that will have gone through every possible thing it's allowing, making sure you can't like put weird things in there. But a common example of this is like who knows with cross-site scripting is you can have JavaScript in an SVG image, right? Because that's something that's not like common knowledge. In an SVG image, you have that run JavaScript code. So there's another interesting thing that'll happen where you have what's called a polyglot, where sometimes you'll have the same stream of data you recognize as two different file formats. And there's like a list of these you can find of ones that have been found before, but I believe there was one in the past. We have something as a valid PDF file and a valid PHP file, right? So if you have like a web server running in PHP that accepts PDFs, that's pretty scary. So you can upload it and be a legit PDF that passes all the checks and then execute some code. Other times, right, like when we're using these file like filters, you can change what called magic numbers. Sometimes they'll work, sometimes that won't. And the magic numbers are reading, it's usually 4 bytes. That'll tell you, okay, what kind of file is this? Another thing you can change is sometimes it'll be checking based off of the request MIME type, which will be like a little header that's like, hey, we're sending application data, right? You can try to change it and see if it makes a difference. But to be honest, all this completely depends on how the server is set up. Because if you explain things in a black box, you should try everything. So, like, what we're going to make you think about is if you have the ability to upload files on a server, right, what would you be going through to go test that? You probably want to go through and say, hey, can I mess with the MIME type? Can I see if there's any new polyglots for this, right, to go mix those together and get code execution? Can I try a really weird file extension and see if it's blocked or not? Right, these are all things you're going to have to just go through and try, because there is no one common like security posture for these things. You just have to try everything and see what works. So, by this point, we should already have an understanding of like the main web vulnerability classes. There's a bunch. I think we're going to go template injection and CSRF in Web 3, which is usually in spring. Insecure deserialization is a big one. That's basically when you're trying to deserialize something like JSON, but you confuse what is in the data versus what is in the code, and then you can run user supplied data. So generally, you just learn rules like in CTFs, because web exploits are super common in CTFs, especially root ones. But this is like the exploitation stuff is very, very specific. The enumeration works pretty much everywhere. Anytime you're going after like a large like company or like big black box pen test, you're doing the same set of steps for enumeration. So, and then just like in that site, you can always go through and see, hey, is there a known exploit? But that's an easy win. So. Finally, I just want to go over some like very basic like neat tricks that don't really fit, but are still like useless. I use a lot of these. One of them is if you have arbitrary JavaScript execution, right? Where JavaScript, in my opinion, is not a very fun language to execute things in, because you can't like run a lot of code, but you can't automatically download files with it, right? So imagine you have a cross-site scripting exploit and you turn it into code execution. Well, you can automatically assemble, right, like based off of JavaScript content, an executable and then call a function to go download that on people who visit that trusted website. And then you have like a sort of like watering hole attack, what's called, where folks who visit that site and get hit by that XSS payload will see a file being downloaded from this trusted site. And this technique is called HTML smuggling, was used by FA2025, who is believed to be the Russian SVR. They're like actual bad guys using this tactic. So it's interesting XSS payload. Another thing is, if you run the core software that's not exploitable, a lot of times if they have extensions or plugins, that'll increase the attack surface a lot, especially if the folks are not like awesome programmers. So you see this a lot with the content management systems, sometimes like PHP will have like plugins, right, like the filters I talked about. You can find this like Python, right, which is another thing that will increase your attack surface. Another thing is just always check to see what your logging limits are. A lot of times for like Active Directory, for example, which is not a web app, going to lock you out. With web apps, it's a model differently. We rarely lock you out, and you're going to be vulnerable to brute forcing. The last one, and this is like specific, but it's a really, really fun one, is if you have a server-side request forwarding exploit, which is an exploit where you can make the server reach out to different web pages. So an example is like, let's say like a down detector website, like something that's checking service uptime, and you can supply as a parameter to it, hey, I'm going to check this website, and you send out a web request to that, right? If servers running iOS and Windows, sometimes server-side request forgery will lead to instant compromise. And this is a quirk of Windows we'll go into, where if it visits an SMB share, it'll automatically log in. So sometimes SSLI can lead to code execution. But that'll become more apparent, I think, later on in how the Windows authentication stack works. So that's everything. I wanted to keep this a bit shorter. I'm going to say I didn't have time to go add a new box to Cyber Range. I was busy this weekend with family. There will be new stuff you guys to go hack into as of next week. But in the meantime, I saw folks haven't gotten the flags in yet for the first like NetSec box. So instead of going over it, the last time I'm going to give you guys some time back. Does anyone have any questions before like I call it for the night? All right, that's easy enough. Is everyone still able to access their Pony OS boxes and the Cyber Range? Okay.
Any questions about training? Anybody currently training on CyberBus?
I know Ray is.
What was that? Who that?
Yeah, that's how we're just at the top of the weekend, right?
Yeah, you should be able to just VPN in. If it doesn't work, we can regen it, but it should work.
Because we have to do it last. I was pinging, I could ping like, the DNS and stuff like that, like when I was like around. Then it was working when I was trying to ping like this specific thing. I logged out of it, logged back and checked out about it works now, so I was like.
Yeah, I mean, I noticed, I think it gets a little overwhelmed when everyone does it during a meeting. When I've gone home and tested it, it's worked fine every time, at least on my end, even off the Ronan. But yeah, I mean, if you can cause something weird that, I can't replicate, I can go take a look. Or you have access to it, you can go take a look as well.
Got a question from me in the back?
Yeah, so.
Yeah, just something technical. Maybe a text box you can, so you can only access the text box from the Illinois.
So this has gone back and forth. The Illinois restriction is from Ingrid's firewalling. It's been going back and forth. I think the Pony OS boxes should be able to be accessed anywhere. If you run the VPN on that, like through the Pony OS web login, you will be able to access the Cyber Range from anywhere, because the Pony OS box and the Cyber Range are like right next to each other, the 2 floors up in this building, and you can bypass that because that's already on Illinois Net. The issue is if you go home and try to VPN into the Cyber Range, I think that's going to be blocked off. If you're not, but you can get around that by just going to a web login and VPNing in from there, and you should be able to access it, if that makes sense.
Yeah, for people who run locally. I mean, they virtualize on this locally.
Yeah, I think you're going to have to be on Illinois Net to do it. We're actively trying to get that fixed, but that's kind of.
There's this won't gather around. I don't think it'll work. You could eventually figure out a way to make them outside, like goes through like Cisco VPN.
Yeah, I was thinking if you turn on Cisco VPN, because then you could access
Do they actually like stack? I very rarely see VPN stack and not explode.
It's theoretically possible, but it's. I would ask you.
Oh, no, we've already emailed them to try to get it fixed. We're just waiting on them. Yeah.
That would be something sound. If we VPN, why can we, you can VPN within a VPN, but it's tough. Yeah, but my point is like, if we VPN into like the cyber range, right? Even on any network, we're technically accessing all the material from that server, which would be on an Illinois net. So that's it.
We can't access the VPN server.
You can't, oh,
It's all the same thing. The VPN server is, I think, on the PF sense, it's on the same Proxmox. Right, so that's I think it's firewalled off.
so we're on this one, so we can't even hold it, we can't use it.
Yeah, because we tried even like hole punching with like SSH forwarding, and it was just not working. So we will fix it eventually.
I think VPN with VPN is possible for this case.
Doesn't it destroy performance usually, or no? Unless you're doing like WireGuard. WireGuard's good about that.
I'm not sure. I don't think Cisco VPN is that bad. In terms of, we can try